Namaste. Good morning. Myself KV Muralidhar Sharma, a research scholar in educational technology as applied to engineering thermodynamics at VTU Karnataka. I'll be dealing about, I'm talking about basic thermodynamics. In the domain of mechanical engineering, my target students are third semester UGC in mechanical. Good morning. Myself, KV Muralidhar Sharma from Jyoti Institute of Technology, a research scholar in educational technology. My work is in applying engineering thermodynamics to educational. Good morning, myself Muralidhar Sharma from Jyoti Institute of Technology. My research is in developing a thermodynamic learning system. This is applying the concept of educational technology in engineering thermodynamics. My present deliberation is on the domain of basic thermodynamics, the topic being thermodynamic systems and boundaries. The two key concepts being the systems and boundaries and the dynamics of systems and boundaries. Obviously, at the end of this session, any student should be able to learn two things. What is a thermodynamic system? What is the importance of its boundaries and surroundings? And he should be in a position to define different types of systems and different types of boundaries. Let's quickly get into the first objective. The first object: what is a system, what is a boundary and a surrounding? Let's quickly come to the academic definition. A system simply means some portion of the universe that we wish to study. Doesn't make much sense, but that's how it is. Let's try to make it a bit more elaborate. The better way of defining a system from engineering perspective could be a quantity of matter or a region in the space chosen for study. Yeah, we have simply defined a system from academic point of view. That's not enough, because the moment we have defined, some obvious questions comes into the mind. When we define a system in terms of say some portion, universe, a quantity of matter, a religion, space, it doesn't look like we are engineering student. It looks like almost we are looking in, we are dealing a philosophical subject, and this is something an engineer student is unfamiliar. Unlike in mechanics, when we define mechanics, we obviously take the help of a rigid body, which is something visible, which is something perceivable. Whereas here we deal with abstract terms, like already we talked in terms of our academic definition, some portion. Some portion is a abstract term. Universe, again, looks like a region in the space, a quantity of matter. This all looks quite abstract as against the specific in probably design or other subjects we deal with. And that's how exactly it is. Let's understand, because the scope of thermodynamics is almost universal, unlike a design or mechanics or hydraulics. Here we can study anything and everything, and anything we study that becomes a system. Anything we study that becomes a system. So what we study is broadly could be either a quantity of mass or a region in the space. Let's focus here. A region in the space represents a volume. A quantity of mass, a quantity of matter represents a mass. Let's take example: an air conditioning, an aeroplane, a refrigerator system, a power plant, or even a human body, or even for that matter a dog or animal, can be a focus of study, which becomes the system. Yeah, we have understood what is a system. Our understanding of the concept of systems is incomplete if we do not understand exactly what we are studying. to understand what exactly we are studying in a power plant, we need to put some boundaries. If we do not put the boundary, the question comes, are we studying only this part, namely cooling tower? Are we studying only the material transactions? Are we studying only the exhaust gas? It can be anything depending upon our requirement. So if we have to bound our requirement, and what bounds our requirement of study is what we call as the boundary. So without the concept of boundary, the system does not become exact. So that's exactly what we are trying to see. Now let's see the next slide. You can see here a red dotted line which constitutes a boundary. We are studying only that portion, that region, that mass within the boundary. Now here is a typical concept. So you can appreciate this as a reason for what is in and what is out. A tube, a flow can be infinite unless otherwise we put some limit. The limit is imaginary. That's what we call it as a fixed quantity of mass like this, or it can be a fixed region in the space. That's what we exactly define a boundary as. Yeah, now let's quickly get into the rest part of the left out part of the first thing, the surroundings and the boundary. Once we define what is a system and what is the system, we have understood, the concept of the boundary becomes very evident. So the system, surrounding and boundary are inseparable. A system cannot be defined without the surrounding, and of course it cannot be defined without a boundary. A system, surround and boundary goes hand in hand. So having defined the system as uh, any any quantity of matter or region in the space which we want to study. That means what we want to study is bounded either by a space, a volume, or a matter. We study either a fixed matter or fixed volume. So what differentiates what we want to study and from that of what we do not want to study is exactly the boundary. Yeah, let me repeat. What differentiates between what we want to study and what we do not want to study? Yeah, this is what we want to study, and this is what we do not want to focus our study, and that the differentiator between these two is what we call it as a system. A more academic definition of surrounding or the boundary could be a surface that separates the system from its surroundings. Obviously, what is a surrounding? Anything outside what we want to study becomes the surrounding. It's either a mass or the region outside the system. We can call it as a surrounding. Having studied what is a system, what is a surrounding, and what is a boundary, let's move on to the second objective. The second objective is what are the types of systems and boundaries. I wish I would like to cover this in my next video. So to quickly recapitulate, we have the concept we wanted to learn here is about system and boundaries, and the first objective being the defining a system which is very abstract, which is not very specific, and which is quite evident, and the system cannot be understood without the concept of boundary. Hence the boundary is important. Thank you.